Hi, hello everyone. Welcome back to our channel Chemistry with RK. So, firstly, I would like to request everyone, those who are new to the channel, so please do subscribe and don't forget to click on the bell icon. So, let's continue with our previous concept, that is solutions. And in the previous lectures, we have discussed that types of solutions. Okay, and now in this lecture we are going to define, or we are going to understand about the properties of the solutions. So actually, when it comes to binary solution, we know that we have discussed that there will be two components called as solute and solvent. So in this particular lecture we are going to talk about the behavior of solute and solvent in that particular solution. So whatever it may be, if you take alcoholic solution, then how the solute and solvent we have in that alcoholic solution, how they are going to behave. So what exactly kind of behavior they are going to show. So in that particular aspect, the first thing we are going to talk about solutions is the strength of the solution. So generally all types of solutions will have their own strength. So generally we call that strength as concentration, and to define the concentration we have so many terms. They are called as concentration terms. So slowly in this lecture we will try to discuss few concentration terms like weight percentage, volume percentage, weight by volume percentage, molarity, normality, molality, mole fraction. So all these comes under the concentration terms. So what does it mean, sir? So we are going to define all these seven concentration terms individually, and among these seven terms, concentration terms, so we can use any of them to define the concentration or strength of the solution. So let me start with solutions. And firstly we will try to define what is strength of solution. Strength of solution. So generally we define this strength of solution with respect to the amount of solute in grams present in 1 liter of solution. Okay, so the strength of solution can be defined as the amount of solute in grams present in 1 liter of solution is called as strength of the solution. So let me just try to write down that. Okay, it is the amount of solute in grams present in 1 liter of solution. Yes. So we need to take the solute weight in grams and then solution's volume in liters, so that we can able to define the term strength of solution. So we can also call this the term strength of solution as concentration. So we are going to learn more about the term concentration in this lecture. So firstly, let us finish this. Okay, strength of solution can be defined as it is the amount of solute present in grams present in 1 liter of solution. So we can write down the formula like this. Okay, if we just try to write down the strength of the solution can be defined as amount of solute. This must be taken in the grams, taken in volume of the solution, and this must be taken in liters. So this is the very important formula to define the strength of solution. So this is very important. So if you understand the concept behind this, and then we are going to start about the concentration terms. Okay. So firstly, what could be the units for this? Units for strength of solution. Okay. Units for strength of solution. Units for strength of solution. Yes. This from the definition we can say that it could be gram per liter. We can say gram per liter, or gram per decimeter cube, because 1 liter is equal to 1 decimeter cube. Okay, so these are the possible units for strength of solution. Hope you understood. So this is the formula we generally use to calculate the strength of solution. And now in general we have so many concentration terms actually. So let me just write down them here. Concentration terms. Concentration terms. Yes. So what do you mean by concentration terms, sir? So generally the terms used to define the concentration. So for that we have so many concentration terms. So let me just give you the list actually here. So that is the weight percentage, weight percentage, weight percentage, or it is also called as mass percentage. Okay, in few books they give weight percentage, and then in few books they give mass percentage. And then the next one, that is volume percentage, volume percentage. And then the next one is weight by volume percentage, weight by volume percentage. And then we are going to start with the very important one, that is molarity. We generally represent with capital M. And then later we will go with normality, normality. And then yes, it is denoted as capital N. And then we are going to start molality, which is denoted with small m. And then the last one, that is mole fraction. Mole fraction we generally represent this with capital X. Okay, yes. So these are the concentration terms we are going to discuss, individually. Okay, so before we start the concentration terms, let us just simplify the concept in order to understand the concentration terms in a better way. So let us just define the things for our convenience. So we know that in a binary solution we have two components, they are solute and solvent. And now just if we see here, then I have taken solute and solvent. And now from this particular class till the end of the chapter, if you see the suffix 1, then please try to understand I am talking about the solute. And if you see the suffix 2, then please try to understand, so I am defining about the solvent. So here I wrote for solute, I wrote W1, which is nothing but weight of solute. And then GMW1, gram molecular weight of solute. So if you see all the suffixes I taken as 1, so which means that I am talking about solute. If you see suffix 2, then which means that I am talking about the solvent. Hope it is clear. And now let's continue. For solute, let us take or let us define or denote this weight of solute as W1, gram molecular weight of solute as GMW1, number of moles of solute. And this is very important to remember, very important. So generally number of moles can be defined as weight of solute by gram molecular weight of solute. If we want to define the number of moles of solvent, that is weight of solvent by gram molecular weight of solvent. Similarly, V1 is the volume of solute, V2 is the volume of solvent, and now once if you know the individual moles of solute and solvent, if we add them, we are going to get the number of moles of solution, which is going to come out as N is equals to N1 plus N2. Sum of number of moles of solute plus solvent number of moles gives us the number of moles of solution. So once we know the individual moles of solute and solvent, by adding these two number of moles we are going to get the solution moles, and now we can able to define the mole fraction of solute and also mole fraction of solvent. So mole fraction of solute can be written as the ratio of number of moles of solute to the total number of moles of solution. Similarly, mole fraction of solvent can be defined as the ratio of number of moles of solvent to the total number of moles of solution. So I have defined each and everything here, and then I gave the meanings of all the terms involved in this, and now by adding the weight of solute and weight of solvent, we are going to get the weight of solution. Generally, I am representing this as capital W. I am going to use this all notations. That's why before I start, I am just trying to give you all these notations. And now, volume of solution is nothing but the sum of volume of solute and then volume of the solvent, which gives us the total volume of the solution. I am taking it as capital V. As I told you already, total number of moles of solution is nothing but number of moles of solute plus number of moles of solvent. Hope it is clear. So please, again I am just recalling, that is W1 is the weight of solute, GMW1 gram molecular weight of solute, N1 number of moles of solute, which can be defined as weight of solute by gram molecular weight of solute. V1 is the volume of solute. X1 is the mole fraction of solute, which can be defined as number of moles of solute to the total number of moles of the solution. Similarly, W2 weight of solvent, GMW2 gram molecular weight of solvent. N2 is the number of moles of solvent, which can be defined as the weight of solvent by gram molecular weight of solvent. And then V2 is the volume of solvent, X2 is the mole fraction of solvent. Again we can able to define this as the ratio of number of moles of solvent to the total number of moles of the solution. Please try to take the screenshot. Okay, let's start with new Josh, that is weight percentage. The first concentration term is weight percentage. So first, to define weight percentage, we need to know what is weight fraction. So weight fraction can be defined as the weight of solute per weight of solution. What does it mean? So we generally denote this weight of solute with small w1, which I just gave in that table. So weight of solute is w1 and weight of solution is capital W. So we can define weight fraction as it is the ratio of weight of solute to the weight of solution. So, that particular expression can be written as weight fraction is equals to W1 by W, and this weight of solution can be written as W1 plus W2. Hope you know. So that is weight of solution is equals to the sum of weight of solute and solvent. And now once after we know what is weight fraction, and let's move to weight percentage. So the representation is also very important. In the competitive exams, they will be using this notation especially. So whenever we see this weight by weight percent, that is nothing but weight percentage. I'll tell you what exactly this particular representation mean within just a few minutes. And now weight percentage can be written as weight fraction into 100 times. That is W1 by W into 100. So that we can also write it as W1 by W1 plus W2 into 100. And now this is what the general idea about the weight percentage. And now when it comes to competitive exams, let us learn the same things how to derive for our convenience. So let us try to understand the same things if they give for competitive exams, how to derive. So actually we define this as mass of the solute present in 100 grams of solution. Yes, the same weight percentage can also be defined as this. Now, what does it mean, sir? The amount of solute or the mass of solute present in 100 grams of solution can also be termed as weight percentage. So, how to understand this, sir? So, let me just give you, suppose let's say, if we have this type of notation, yes, we will be observing this type of notations in the entrance exam questions. So suppose let's say they give X weight percentage of glucose. Suppose they may give some other compound also. So suppose let's say if we see this type of notation, then how to derive or how to write this for our convenience. And now the exact meaning of this is X grams of glucose is present in 100 grams of solution. Yes, what exactly mean is this? So that is X weight percentage of glucose means X grams of glucose is present in 100 grams of solution. And now what is the weight of solvent we can expect in this? Obviously it is going to be 100 minus X grams of water. Yes, generally if they don't give any particular solvent in the question, then we can take it as water. And now here our glucose is going to behave as solute, and then water is going to behave as solvent. Yes. So this is what exactly how to derive our required data from the given expression. So when we have x weight percentage of glucose means x grams of glucose is present in 100 grams of solution, which makes out as 100 minus x grams of solvent, obviously. Okay, so let me give one particular example here to understand this in an easier way. So let me take this 90 weight percentage of sucrose. 90 weight percentage of sucrose, suppose. And now what does it mean, sir? So please you try to write down your answers, or maybe you try to make out the things I'll be discussing anyway. So 90 weight percentage of sucrose means 90 grams of sucrose present in 100 grams of solution. Yes, there is no change in that. If this is 100 grams of 90 grams of sucrose is present in 100 grams of solution, how many grams of solvent we are going to have? Obviously 10 grams of water or solvent we are going to have. Clear? So this is how we make out the things easy for our problem solving. Hope you understood. I'll just take one example here to understand it in a better way. You please try to take the screenshot. Now I'm going to take a problem. So the given condition is calculate the mole fractions of both the components in a solution having 98 weight percentage of H2SO4. This is the question. Yes. So they just gave only the weight percentage, and then they are asking the mole fractions. Now how to tackle this question or how to solve this question? So it's very easy actually. The question may look like complicated, or maybe what did they give? They just gave weight percentage, and then they are asking the mole fractions. So how to solve this actually? So first thing is we need to write this particular given weight percentage in the easier manner. Just now I told you. So you please try to write down this as 98 weight percentage of H2SO4 means 98 grams of H2SO4 is going to present in 100 grams of solution. Yes, it is clear. And now obviously how many grams of water or solvent is going to be there? Yes, 2 grams. So this is what we need to write down. And now once after we get that, so let me just take, we have H2SO4 actually, we have H2O. And now H2O weight, we already got to know that weight of that is H2SO4 is 98 grams, and weight of water we got to know it is 2 grams actually. We got to know that is 2 grams from the given data. And now the gram molecular weight of H2SO4 is 98, and the gram molecular weight of water is 18. How come this gram molecular weight becomes 98? So gram molecular weight of any compound is the sum of atomic masses of all the atoms. So what does it mean? So for each hydrogen 1 gram, so 2 hydrogens 2 grams. For each sulfur 32 grams, 32 plus 2 34, and now 34 plus for each oxygen it is 16. So 16 fours are 64. 64 plus 34 gives us 98. Similarly here also 2 hydrogens 2 grams, 1 oxygen 16, so altogether it is 18 grams. And now when we know weight and gram molecular weight, we can easily find out the number of moles that is going to come out as 98 by 98, that is 1 mole, and similarly here 2 by 18 it is going to come out as 1 by 9 moles. And now when we have individual moles, we need to calculate the total number of moles, that is going to come out as 10 by 9. Okay, so how we get 10 by 9 here? That is 1 plus 1 by 9, which is going to come out as 10 by 9. And now to define mole fraction of H2SO4 and H2O, we know all the required terms are there now. So X1 can be written as N1 by N, which is nothing but 1 by 10 by 9, which is going to come out as 9 by 10, which is 0.9. And now similarly, the mole fraction of water can be written as N2 by N, which is nothing but 1 by 9 by 10 by 9, which is going to come out as 1 by 10 and then 0.1. Okay, so this is how we are going to solve this type of problems. So just they gave weight percentage and they are asking the mole fraction, so we can easily derive them. Clear? So from where I have written all these things? From here. And then from where I have written this? From the previous, I just made the things easier for our problem solving. So from there we have derived everything. So please try to understand carefully, and any queries please put it in the comment section. Okay? Yes. And now please try to take the screenshot of this. And now let's move to the second one, that is the volume percentage. So just I'm going to do some small changes in this weight percentage. So please try to identify here. So weight percentage can be, before we define weight percentage, we just made out the things for weight fraction. Similarly, here the second one is volume percentage. To understand volume percentage, we have to make things easier, so that we have to define volume fraction and then volume percentage, and then the simple way of understanding. So just try to understand here. So I'm just trying to make some changes here. The second one is volume percentage. So how do we define this, or how do we denote this? So that is W1 by W. So obviously this is V1 by V. And now how to define volume fraction? So here weight fraction, it can be defined as weight of solute by weight of solution. So since it is volume fraction, so we are going to define volume of solute to the volume of solution. That's it. Okay, so volume of solute, that is generally represented as V1 by volume of solution, that is V. That's it. And now just try to understand VF, that is volume fraction, it can be written as, okay, that is V1 by V can be written as V1 by V1 plus V2. Similarly, next that is volume percentage. So volume percentage can be written as V1 by V, can be written as volume fraction into 100, can be written as V1 by V into 100, and finally we can write down that is V1 by V1 plus V2 into 100. Yes. Okay. Yes, this is what normally volume percentage is. And now when it comes to the entrance approach, similarly, like there we have defined mass of solute present in 100 grams of solution. Here the volume of solute is present in 100 ml of solution. Now let's understand the same volume percentage for entrance exams. So suppose let's say we have volume of the solute present in 100 ml of solution. Yes, similar to the weight percentage. And now suppose let's say we have X volume percent of ethyl alcohol, suppose. And now how to write down this, how to understand? So simple, that is X ml of C2H5OH is taken or present in 100 ml of solution. Yes, this is what we need to understand. So obviously, what is the remaining solvent volume? That is 100 minus X ml of water. Generally, if they didn't give anything, so we can take water as our solvent. Hope you understood. So this representation is very important to convert. As of our convenience, we have to write down like this, so that our problem solving will become easier. Okay, and now let me take another example here. Suppose let's say we have, suppose let's say we have 40 volume% of ethyl alcohol. Then how many volumes or how many ml of ethyl alcohol is going to have 100 ml of ethyl alcohol, is going to present in 100 ml of solution. So how much is the volume of water? So that is 60 ml of water is going to be present. Same, let me just go with respect to the third one, that is weight by volume percentage. Very important. Just I am going to make some small changes here. That is weight by volume percentage. And now weight by volume percentage can be written as weight by volume percentage. So simple. And now before we start talking about weight by volume percentage, we need to understand weight by volume fraction. Okay, so weight by volume fraction can be written as, okay, W by V fraction. Okay, just this is the representation we are making for our convenience, that's it. So weight by volume fraction, okay, can be written as, please try to guess, that is weight of solute, that is going to be W1 by volume of the solution, that is V. And now this weight by volume fraction is going to be written as W1 by V. Similarly, we can write it as W1 by V1 plus V2. Similarly, now finally that we can write down weight by volume percentage can be written as, okay, so weight by volume fraction, okay, so we can write down here, that is weight, okay, by volume fraction into 100. Yes, so simple. And now we can write down W1 by V into 100, W1 by V1 plus V2 into 100. And now the same kind of approach if we just think about for objective exams. So how to understand this? Since we are writing that weight of solute by volume of solution, we can say that is weight of solute present in 100 ml of solution. That's it. Weight of solute present in 100 ml of solution. Suppose let's say we have this type of representation, X weight by volume percentage of NaOH. Suppose let's say we have sodium hydroxide. And now what does it mean, sir? X grams, okay, so we can write down this as X grams of, this is the compound NaOH, is going to be present in 100 ml of solution. That is very important. And now what is going to be the solvent? That is 100 minus X grams of solvent. And now sir, this is in ml, this is in grams, so how come this is in this can be taken in grams? So we know that density is equals to mass by volume. So here we have in terms of volume, we have in terms of ml. So in order to convert that into weight, so we need to multiply that volume with density, so that we are going to get this into grams. So hope it is clear. So this is all about the three concentration terms. So please try to watch the video thoroughly so that you will understand it more clearly, and then soon we are going to have a problem session on this concentration terms. So see you in the next video with more Josh, with the concept called as molarity, which is going to be very interesting. So don't miss, and then please, if anyone is new to the channel, so please I request you to subscribe and don't forget to click on the bell icon to get the regular updates.